Everyone in this room and all over the world could be eating this. That's 52 credit cards worth of plastic each year. This should not end up in our oceans, on the food chain, or on your family's plate. Instead, it should be used to make these. Batteries and cables to power our EVs, our drones, and our phones. The thought of my children consuming 52 credit cards worth of plastic each year keeps me awake at night. In fact, the thought of them eating any amount of plastic keeps me awake at night. I have to do something about this. It has become my motivation, my responsibility, and my duty. Or why else did I spend all this time at Rice University, MIT, and then become an associate professor of chemical engineering if I can't do something for my children and their children? You see, the Earth's population is rising, and more people need electricity to increase their living standards and to stay alive. In 2023, we use over 25 terawatts of power on this planet, and batteries and grid materials need to be improved or the grid will fail and people will die. Meanwhile, for every 3 people on the planet, there's 2 tons of plastic waste on the environment. And despite our best efforts, that number continues to rise. Now, something about this picture has to change. And that is why TEDxAUD is a green tech, deep tech materials manufacturer. You see, on the one hand, in the battery market, there is a strategic shortage of carbon in the form of carbon nanotubes, while on the other hand, there's an oversupply of carbon in the form of plastics. You see, through my lens as a chemist, I invented a process to take carbon from the one hand to make it into carbon for the other. From my perspective, the entire problem is the mismanagement of carbon. So at TEDxAUD, we are changing the paradigm of deep tech manufacturing by being a green tech manufacturer too. Now, in 2024, we are on the ground floor of commercial success. We are just getting started. We turn plastics into nanotubes to make wires and batteries. You see, plastics are just bundles of carbon and hydrogen, and chemistry is just the science of change. So we change the arrangement of atoms to make different materials from the same ingredients. So we take plastics to make atomically precise carbon structures that we call carbon nanotubes, because they look like a tube. They've got an outer wall and an inner shell. And at the nanoscale, they're tens of thousands of times thinner than the human hair. They look like a rolled up chicken wire with lots of connected hexagons. Because of all the interconnected carbon atoms, they are strong like diamonds. Carbon is normally an insulator, but at the nanoscale, exciting things happen. You engage with the quantum world. The nanotubes conduct heat and electricity. In some cases, they are far superior to metals, especially when you account for how light they are. Just think about ash from a fire. That's how light carbon nanotubes are. And that's great for aerospace applications. And this is where I learned about them. See, I was helping to design a tool that would go to the moon, take lunar regolith, the moon soil, to make solar cells and oxygen. The tool had to be as light as possible to be able to handle the extremely robust, harsh environments. And one critical part had to conduct electricities using very low electrical pathways called field emission. But metals were too heavy, they could melt, and so nanotubes were the obvious answer. Nanotubes conduct electricity, they don't burn, they retain their structure under constant use, so they were the obvious choice. But they were extremely expensive. So instead of buying them, I decided to make them myself. This brought me to my PhD at Rice University, and the rest, they say, is history. Speaking of history, you should know that carbon nanotubes have been around for a very long time. They've been found in pottery dating back to the 4th century, and they've been found in steel dating back to the 17th century. You see, since antiquity, materials have defined our ages. We've had the Stone Age, the Bronze Age, and so on. And several writers and historians have considered that we are now entering the Diamond Age. When you look at the periodic table, all the metals sit within inside those green lines. The modern world as we have today is made up of metals and the various properties that we have from metals. But carbon, that sits on the very top, when in the form of nanotubes, can behave and act in the same way as all these other metals. But remember, they're 6 times lighter than copper. So when nanotubes were first discovered, there was a real flurry of excitement to use them in place of metals. And over the last 20 years, that has been happening. If you drove here tonight, or if you have a mobile phone or a slim battery, you have benefited from carbon nanotubes. We are in the Diamond Age. So as you can see, when I learned about nanotubes, I was fascinated by all their intriguing properties, especially for electrification applications, because we urgently need more electricity. But I would ask myself, if I was going to make these nanotubes, how can I make them in a way that would be sustainable? Because I didn't want the solution to be worse than the problem that I was trying to solve. I wonder what you would do in this situation. In my mind's eye, I had a conversation with my daughter in 10 years' time. And she asked me, was I happy with the choice that I made? My choice was to be an academic, to publish, and to teach, or to go full-time with my company. I thought about all the plastic that she could be eating. I have her life in my hands. I knew I had a technology with purpose and potential. So I left my tenure professor gig and founded TrimTabs because 52 credit cards worth of plastic keeps me awake at night. With our production method, we can eventually divert plastic from landfill to make batteries and cables instead. It's essential for our children, for the planet, and it's great for business. Our process is 60% more efficient than incumbent technologies. So that's 10 years from now. What happens tomorrow? Just this year, we built our first prototype production unit, our MVP. We've got clients across the globe who are looking for our materials. We are a green tech, deep tech materials engineering company. Now remember, when Apple came out with the first computer, it was basically a keyboard set into a wooden box. But they've gone on to change our interaction with music, computers, and phones. We are on the same path with the same vision and the same hunger for change. We are surrounded by plastics. There's literally thousands of years of materials worth just strewn away. We could divert it from the environment and use it to power our future. But in only 2 short years, we've gone from peer-reviewed papers to pilot production. Now we want to see carbon nanotubes in a phone in your pocket. We will be changing the worlds of material and energy. And now I have got double the motivation because I'm going to be a father for the 2nd time. I am doing this because I've worked hard at MIT, Rice University, Swansea University, in the labs, the libraries, and the lecture theatres. I'm doing it because it makes business sense. I'm doing it, most importantly, for my kids, your kids, their kids. We need the energy. We need the plastic out of our environment. We need more value from our materials. So who's with me? As you think about your children potentially eating 52 credit cards worth of plastic a year, I stand here asking you, how can you help to be a part of this better future? I want to work with like-minded visionaries, storytellers, poets, artists, and technologists alike. I want to work with leaders in the energy industry to demonstrate there is hope on the way. Actually, regardless of who you are or what you do, if you want to course correct away from a world full of trash to a world that is energy secure, come reach out, because it is made easier if we work together. I've been on this path for 15 years already, and for the sake of my daughters, I'm not giving up anytime soon. Let's make the decisions today that we will be happy with in 10 years' time. Let's do what's right to usher in a truly just transition. No more eating 52 credit cards worth of plastic. Let's do this.